pipettes. How am I going to do it? With my hand, and I can just pull them out. Now, in order to be able to figure out which ones to pull out, I took advantage of a property of the pens that was different from the pipettes. What's the difference that allowed me to do that? Their appearance. They look different. Okay? Now, there are other types of hand separation as well. Here, I've got a mixture of little pebbles, so gravel, and some sand. And I'm going to use this device to separate them. It really is the equivalent of me going in with tweezers and pulling them out, but this is a faster version of it. And so when I pour it on the sieve and I shake, the sand goes through, the pebbles get left behind. Okay? What is the property that was different between the sand and the pebbles that allowed me to do that? The size. Okay, so large things got trapped, small things went through. We can take it a step further. Let's have the sand and the pebbles and some iron filings. Mix them up. Now, if I had no life, I could get a magnifying glass and a set of tweezers, and I could pull out by hand each sand grain, put it in one pile, and the iron filings, put them in another pile, and the gravel, and put it in another pile. Is that plausible? Like possible? Is it the best way to do it? No. There's another property I can use to separate the sand from the iron. What's something that iron does that most materials don't? Yeah, attract it to a magnet. And so I can take a magnet and I can just stir it around here and I'll pull out the iron filings. Okay? And so I use the property of magnetism to allow me to separate those materials from each other. Okay, you take a round piece, fold in half again, and then you open it up. You've got a nice little cone that stuff can get through. Pop it in here, and I'm going to this time use, again, sand and gravel, but a bit of water as well. Okay? And it doesn't like to stay mixed, so I'm going to have to keep on swirling it around. I'll drop a bit of that in there. And what's coming through the bottom? See any rocks coming through the bottom? Okay. In general, what's the big difference between this stuff and this stuff? If you had to pick the most basic word to describe this stuff versus this stuff. Liquid and solid. So what is the property that is different? The blank. The phase or state. The state. So solids get trapped, liquids go through. Now, there's a slight exception. Is this clean-looking water? No. There was a type of solid that went through. A solid that when it's with water isn't really a solid anymore. It's not because it melted, it's because it dissolved. Okay? So dissolved solids can go through. What's a name for something that has a dissolved solid in it? Solution. Okay? So solutions will go through, solids get trapped. Now these things have different names. The stuff that actually went through the filter has been filtered. It's called the filtrate. The crud that got left behind has a name that most people associated with scummy, cruddy, gross stuff. Anybody know the name of the stuff left behind the filter?
Soot.
The residue. Okay, it's not a nice sounding word. It sounds dirty. And this usually is the dirty stuff that you tried to get out. Okay.
Yeah.
Okay. So this apparatus here is called a distillation apparatus, but because it's a long name, it's usually shortened to just still. And when you hear the word still, what do you think of? Actually, I'm thinking more like somebody in the bayou, in a cabin,
Moonshine.
making moonshine. Okay, so this is how you you make hard alcohol, or you concentrate alcohol. So what we've got here is a mixture of water and some red food coloring, and I'm using red food coloring simply because it's nice and visible. Do you think that the red food coloring has the exact same boiling point as water? No. So when I heat up the mixture of water and food coloring, the temperature is going to rise and rise and rise. And then it's going to get to the point where one of the two liquids starts to boil. And then for reasons that I'm going to explain in a later class, the temperature actually stops rising. And it can't go any higher until all of the first material is gone. And so we're going to start making a bunch of vapor. The vapor is going to move along this tube here, and then it's going to come down this tube into the spiral. And I'm going to turn on the water right now. And cold water, and it's cooling the outside of the inner tube. And so when the vapor hits that, the vapor cools off, and what's it going to do? Turn back into a liquid. But it's no longer going to be a mixture of the two liquids. It's just going to be the liquid that boiled first. Okay? Now, when I say just, that's an approximation. Even when you're below the boiling point, are the liquids stuck here? No, there's still always going to be at least a little bit of evaporation. Okay? So it's not going to be 100% pure, but it's going to be much purer than it was. And this is going to take about a minute. We'll do that fast forward, so just keep watching. We're starting to boil here. It's going to happen soon. Are you ready? Come on.
There we go.
Oh, here we go. Here we go. Oh, he's going down. Zoom. It's like the zoom from at Atlantis there. And the question was, is it red still? Let's catch a few drops. And what do we have? Pure water. Pure water.
Drink it.
Okay, so how many of you have been to the IPE? How many of you have been on the Gravitron? That's the one where you're up against the wall, it starts spinning, and then the floor falls out, but you stay stuck to the wall. Okay? Now it's called the Gravitron because it simulates gravity, but it's not actually gravity. It's something that you're going to learn a bit more about when when you guys take Physics 12, which I'm sure all of you guys are going to do. But basically what's happening is your body's trying to go in a straight line, and the ride is trying to turn around you, and that makes it feel like you're being thrown to the outside. But you're not. You're actually being pulled to the inside by the ride, but your body can't distinguish between the two. The Gravitron goes fast enough that the force you feel seems like it's stronger than gravity. We can do the same thing to help with this device here called a centrifuge, to help separate objects based on their densities. And so if I have two objects, one's really dense and one's less dense, and gravity's pulling on them, if they are allowed to flow, the more dense one is going to try to slide underneath the less dense one. Won't work if they can't flow, though. So if I wanted to separate different solids, like say some sand and rocks and flour, they don't flow so well. This only works well with small amounts. And this was wet, so it's just going to make a big mess here. But anyways, they're mixed up now, and they're not separated based on density. What we can do is add a bit of water so that things can slide past each other. And then I could shake it and then just let it sit, but that's going to take like days or weeks for things to settle out properly because gravity isn't that strong. Instead, I'm going to stick it in here, which spins really, really fast. And one of the only times I've sworn in class was when it was at top speed, and then my thumb came up and it whacked me in the thumb. It was awful. I'll try not to do that today. And as this is spinning, it's as if you've got like Jupiter gravity or something like that. Okay, so the force felt in there is going to be many times stronger than gravity, and that's going to make the dense things slide down more quickly than they would have otherwise. This is heavily geared, so small turns at the bottom equal high speed up top. Separated it right out. Yeah. So the glass is now separated from the glass. And you can see down there that our base sand was actually more dense than our black rocks. You see that? Okay. And then on top of that, we've got the flour, and then on top of that, the water. And down at the bottom, we've got the glass.
Jupiter gravity.
Any questions?
Retry.